In this video, I'm going to show you a PWM demo, and we're using the Data Acquisition Control system. Now for this system, I've chosen the USB 6211 hardware option. So we're going to control the speed of this fan using PWM, and the deflector here will show you how fast the fan is going. So let's go ahead and jump into LabVIEW and start programming. The first thing I want to do is generate this PWM signal. So I'm going to right click, I'm going to go to Express, Input, and then Simulate Signal. So this will pop up and have me configure the signal. PWM is a square signal. I found that 1 kilohertz works really well for my system. I'm going to ignore this notification for now. And the next thing I want to configure is the samples per second. Now, the signal itself, this pulse signal we're sending, is actually made up of a bunch of samples. So it's not necessarily a continuous signal, it's got a bunch of samples within it. So next thing I need to decide is how many samples do I want for each period. And I found that 100 samples per period works pretty well. So I'm going to take that 100, I'm going to multiply it by my frequency and get 100,000, and that's our samples per second. So the next thing I want to do is deselect this automatic, and now I want to say how many periods of the signal do I want to output. So I've decided that I want to do 2 periods, so how many samples are in 2 periods? Well, I've just decided I wanted 100 in a single period, so multiply that by 2, and we get 200 samples for 2 periods. And you'll see up here in the preview, it'll update with all the configurations I make as I go. So one thing I'll notice is it's from -1 volt to 1 volt. So I can go in and change that here. So first thing I want to go and change is the offset. The next thing I want to change is the amplitude, because my fan can only take 0 to 5 volts. So that signal looks pretty good to me, so I'm going to click OK. Next thing I want to do is place down a DAC assistant and feed out the value to my fan. So I'm going to right click, Measurement IO, DAC MX, and then DAC assistant. So place this down, and first thing it's going to ask us is, are you wanting to acquire a signal or generate? Since we're outputting from the DAC card to our fan, we're generating an analog output, and it's a voltage. And I know just by the way I've wired it up that my the channel I'm using is analog out channel 0. So we'll select that. We'll click Finish. And then a few other things to configure before we start. Like I said, the fan can only take 0 to 5 volts, so we'll change that. And I actually want continuous samples, and I want to write out 1,000 samples at a time. And that's all I need to change, so I'll click OK. And it's going to ask me in a second, it's going to say, you've asked to create a continuous signal. Now, do you want to put this signal in a while loop? So I'll go ahead and say yes. So now this is going to run over and over again until I tell it to stop. So we'll expand it, move it around a little bit so we can drop the simulate signal in there. So we'll wire these guys together. And now I want to control the signal. I want to change the duty cycle so that I'll change the signal going out to my fan. So I'm going to expand this. I'm going to click on error out and actually change it to duty cycle. And I'm going to right click and create a control on my front panel so I can actually control this value. Okay, and the next thing I want to do is I want to actually see the signal as I'm sending it. So I'm going to right click, I'm going to go to create graph indicator. Okay, so let's go to our front panel. There's one last thing I want to change. I'm going to just change the type of control I have. So I right click, I went to replace. We're going to replace it with this slider. expand it down, and duty cycle goes from 0 to 100. And now we're ready to run it. So I'm going to start with it down at 0. We'll run it. You'll see I'm not sending out, the signal I'm sending out has 0 duty cycle, so the signal is 0 volts. But as I crank it up, you can see the signal changing. And I don't know if you can hear, but there's a high-pitched hum coming from my transistor, and that's the signal being sent out at 1 kilohertz. So we'll crank this up and see our fan move. And you can see on the graph indicator that as I change the duty cycle, the signal changes too.